Let's talk about what we're going to talk about with hematology. I need to make sure that you become very, very well versed in your anemia identification. You just have to. You're going to see CBCs all the time, and you need to know what to look for and how to do it. Then there's a platelet problem that you just need to know. When it comes in, you need to nail it, and so I want to make sure you do that, although it's not real common. But when it walks in, you cannot miss it. And then finally, we're going to look at 3 CBCs and just kind of help walk you through them so that if you're struggling with CBC interpretation, you'll have some tools that will help you with them. But I'll tell you, people struggle with CBCs all the time. They just do. I get CBCs emailed to me. I get CBCs from colleagues with calls. They're just things that people struggle with. So if you're not quite there yet with CBCs, I think what I give you will help you, but you'll just continue to learn as you go. All right, so that's where we're headed for about the next, 60 or 65 minutes. Here's how I'm going to win my bet. If you are struggling with identification of the anemias, I think I know why. Your brain is missing some key facts. And the minute I put those facts in your brain and you see how they're pertinent, all of a sudden your neurons are going to make connections and boom, you're going to see it. All right? So that is my goal for you in the next hour. But I got to give you that lab background, and a lot of nurses and NPs just never got it. Then we'll launch into the anemias, of which we're going to talk about iron deficiency anemia first. It's the most common worldwide, so you got to know all about it. We'll look at anemia of chronic disease. It's the anemia that accompanies poorly managed chronic diseases, and I'll tell you some more about it when we get there. Almost every exam has a thalassemia question. If you talk to anybody who's recently taken the exam, they all tell you, oh yeah, I had a thalassemia question. If they tell you, I didn't have a thalassemia question, they missed it, right? And I want to make sure you don't miss it. So perk your ears up when we get to that section. And then we'll talk about a vitamin B12 and a folate deficiency. We talk about them together. We'll do that. We'll look at ITP, immune thrombocytopenia. That's the platelet problem. We'll look at the 3 CBCs, and then we'll take another break. All right? So let's get going. And I want to make sure that we all start on the same page. And here's a question you have to be able to answer. How do you know that somebody's anemic? Like, what do you look at? What are you supposed to look at to let you know that a patient has anemia? Well, it turns out that what we are looking for is a reduction in one or more of these RBC measurements. So look at what you look for: a reduction in hemoglobin, hematocrit, and or red blood cell count. Because if there's a reduction in one or more of those, your brain needs to be thinking about anemia. So here's a patient and here's a question. I want to know if you think this patient is anemic. Well, one of the 3 things you look for is a red blood cell count. And on a CBC, when you see RBC, that's your red blood cell count. So in this patient, it's 4, a little low. Hemoglobin, that's the second one you look at, a little bit low. The third measure is crit, a little bit low. So what's your answer to this question about, is this patient anemic? What's your answer? Yes, of course they're anemic by all 3 measures. What people ask me all the time is this: hey, Amelie, do I need to memorize all those lab values for my exam? And I always tell them, listen, please don't waste your brain space on that. You need to put more valuable information in your brain than memorizing these lab values. So let me tell you this. On CBCs especially, they're going to give you the normal values. But it doesn't matter what lab in the world does the values, they're all different. And it doesn't matter what lab in the world someone's H&H turns out to be 30 and 10 in, they're anemic. So it doesn't matter whether the lab is in Baghdad or Breaux Bridge, right? If your H&H is 30 and 10, you're anemic. Don't memorize those lab values. My best advice is to be able to recognize those that are way out in left field. But to be honest with you, when it comes to MCVs and MCHs, you should expect to see some normal values on your exam. Don't go wasting brain space on memorizing those, all right? So I would tell you that. Don't memorize them. With that said, there are a few you got to know, and I'm going to give them to you as we get there. For example, don't expect a normal A1C. Don't expect a normal fasting glucose. I'm going to give you those tomorrow. Don't expect normal lipids. I'll tell you that and make you put a star by it tomorrow. So kind of sit tight for right now. With the red blood cell indices, they typically give you normal values. All right? So sit tight on that. Rule number 1. Anemia is never normal. Anemia is never normal. It's never normal. When a patient is anemic, it is a huge clue to you. It might be a clue of a major disease that's going on. It may be a major clue to something else that's going on. So anemia is never normal, and your take-home message is that your job is to make sure you find out what's causing anemia in that patient. So in the United States, there are 3 reasons why patients are anemic. The most common reason is that they've lost blood, and you should know that. The second most common reason we see anemia is that people have a sick bone marrow. In other words, the bone marrow can't produce enough red cells. We think of things like maybe leukemia that doesn't allow red blood cells to be produced. The third most common reason we see anemia in the United States is because people's red blood cells die too soon. Oh, wait, how long does a red blood cell usually live? About 100 to 120 days. So some people, especially in anemia of chronic disease, have red blood cells that just die too quickly. And the bone marrow can't keep up with the need to produce more. So 3 reasons in the United States are these, why people are most commonly anemic. Well, there are a lot of things that can impact your H&H. So when you're looking at a patient's lab values, you always have to take that into consideration. And let's go through these, and I want to know from you how the following characteristics will affect someone's hemoglobin or hematocrit. The first patient is someone with COPD. How would you expect COPD to affect someone's H&H? It's going to do what? Drive it up. So draw an up arrow in that box. How would you expect someone with chronic kidney disease? What impact does that have on someone's H&H? It causes it to be decreased, right? If you don't make erythropoietin because your kidneys don't work so well, you're not going to make red blood cells. So you see a decreased H&H. Hypertension, how does that Emily, I never even knew that. Does hypertension affect H&H? No. So just draw a line going across. It doesn't make it go up or down. What about the next one? A diabetic whose A1C is 13.8. Does that affect the H&H? It sure does. What happens? It causes H&H to drop. Think about it like this. When a patient has anemia of chronic disease, their red blood cells are under a lot of stress. I mean, just think about this. Suppose this morning when you woke up, you weren't a human being, but instead you were a red blood cell. And today was your unlucky day. Because today, you were put into a diabetic whose A1C is 13.8. That means the average blood sugar is around 350 or so. Do you know what a hard day you're about to have? You are a red blood cell, and your job is to swim through blood vessels and capillaries and arteries, and the blood is so thick and sticky. It's like trying to swim upstream. Do you really think you're going to live 120 days? No, you're going to be dead too early. And that's exactly what happens with any poorly managed chronic disease. It could be diabetes, it could be thyroid disease. Almost any poorly managed chronic disease is going to result in a decrease in H&H. All right? So in that box, put an arrow pointing down. What about aspirin use? Aspirin use has no effect on someone's H&H. Now, if you're bleeding, it's certainly going to decrease. But just taking aspirin without a GI bleed is not going to decrease your H&H. All right? What about testosterone use? Wait a minute, does that affect your H&H? Oh, it sure does. What happens to a man's H&H? It goes way up. In fact, sometimes it increases so much with testosterone use that patients undergo therapeutic phlebotomy because we don't like people walking around with crits of 60. You got it? Oh, Amelie, look at the next one. A resident of Denver, Colorado. What do we know about Denver, Colorado? Listen, you don't have to be a geographer to pass this exam, but there are two geographical areas you need to know about. One of them is Denver, Colorado. It's a mile-high city, 5,280 feet above sea level. The air is very, look, thin. If you run around in thin air, you know what your body does? Your body says, whoa, I've been exposed to low levels of circulating oxygen so long that the body compensates by spitting out more red blood cells to try to get more oxygen to the tissues. So people who live at high altitudes have a higher than we would have expected H&H. You need to take that into consideration when you take care of someone like that. The other area, geographical area you need to know about is the Mediterranean region of the world. That becomes important for you with thalassemia. So the Mediterranean region means France, Italy, Spain, Sicily. You got it? That whole area. We'll talk about thalassemias and you'll hear me say the Mediterranean region of the world. So if you don't know a darn thing about directions and geography, you've got to know those two. All right? Everybody with me? So back to a resident of Denver, Colorado. How does that affect the H&H? Increases it. Finally, age. An 84-year-old. What would you expect her H&H to be? Normal? Up? Down? What do you think? A little bit less than normal, and let me tell you why. Your bone marrow functions less robustly as you age. Not huge, but it's just not quite as robust as it was when you were 24 years old. So right now, your take-home point should be this one. Depending on your age and depending on what diseases you have and what drugs you might use and what place you might live, can all affect someone's H&H. And that has to be taken into consideration when you look at what the patient's H&H might be. Is everybody with me? All right, let's keep going. Older patients, as we just said, tend to have a little bit lower H&H than their younger counterparts simply because their bone marrow is not quite as robust in its function. But we never ever presume that an older patient with anemia has it because they're older. We always assume that there's an underlying disease and your job is to go and figure out what in the world is going on with that older patient. About 1 in 5 older patients have something called idiopathic anemia of aging, which means it's just a little bit lower than normal and like they don't have anything going on with them. It's just because their bone marrow is not quite as robust. All right? So I want you to keep that in mind. All right. I'm about to win my bet with you. Are you ready? You ready? Oh, Lordy. I am convinced that I could teach a kindergartner to diagnose anemias because there are 2 things you got to know to graduate from kindergarten. Did everybody? All right, good. There are 2 things you just got to know to graduate from kindergarten. One of them is about size. You got to know the difference between big and little. We look at red blood cell size when we diagnose anemias. The second thing you just have to know to graduate from kindergarten are your colors. Red, green, blue, yellow. You don't need to know magenta or fuchsia, but you got to know your basic colors. And that's the second thing we use to diagnose anemias. So it is size and color. When we talk about the size of red blood cells, you need to know these words. If someone is anemic and their red blood cells are too little, we say they have a microcytic anemia. Micro means small. Microcytic anemia. If someone is anemic and their red blood cells are the right size, we say they have a normocytic anemia. Normo meaning normal size red blood cells, but they're anemic. And we're going to talk about two anemias today that produce macrocytic anemias. The red blood cells are huge. Macrocytic anemia is the term we use to describe people who are anemic and their red blood cells are bigger than we would have expected. Size is very, very important with regard to red cells. So if size is so darn important, where do you go to find out the size of somebody's red blood cells? Well, you go to the CBC, and specifically, we look at their MCV, so circle number 2. So you want to know the size of red blood cells, we look at the patient's MCV. The second thing we look at when we diagnose anemias is color. What makes a red blood cell red? You know what it is? It's how much hemoglobin is in that red cell. So listen. Hemoglobin makes red cells red. If a patient is anemic and their red cells don't have enough hemoglobin in them, we say they have a hypo, meaning low, chromic color, a low hemoglobin cell. So a hypochromic red cell is characterized as a hypochromic anemia. If our patient is anemic and the red cells have the right amount of hemoglobin in them, we say they have a normochromic anemia. And the third one doesn't happen often. But sometimes people are anemic and their red cells are loaded with hemoglobin. If that's the case, we say they have a hyperchromic anemia. All right? So, if the color of red blood cells and knowing how much hemoglobin in them is so darn important, Amelie, what do I look at on an RBC to tell me that? Look at the MCH, right? So circle number 3. So here's where you ought to be right now. You ought to be thinking, all right, Amelie, to diagnose anemias, I'll look at size and color, which means that I have to look at an MCV and an MCH before I can diagnose an anemia, right? Right. All right, that's where you ought to be right now. You got to look at MCV, meaning size, MCH, meaning color. Is everybody with me? All right. Then you should be able to answer these two questions. Here's the first one. I want you to look at this patient's CBC. And my first question to you is this one. Do you think this patient is anemic? What 3 indices do you look at to determine anemia? RBC count, low. Hemoglobin, low. Crit, low. You've got to be thinking anemia in this patient, and you're correct. The second question is, in this anemic patient, what do his red cells look like? Well, you got to look at size and color. The MCV is 104. The normal high is 96. What word do we use to describe the size of these red blood cells? Macrocytic, because they're huge. So this is a macrocytic anemia, and we want to know how much hemoglobin is in them. We have an MCH of 25. Oh, that's normal. What word do we use to describe that? Normochromic. So my question is this. What do his red cells look like? They are macrocytic and normochromic. You got it? So this patient has a macrocytic normochromic anemia. Is everybody with me? All right, let's keep going.